Welcome back, Hampshire science students. This is our second video in a series about density. Our first one covered about the different kinds of theory and the meaning of it. And then today we're going to be moving into understanding how we can calculate density. So let's take a look at a couple different example problems together. Okay, first off, I have a sheet here in front of me that I printed off. If you have a printer at home, you could do this if you wanted to. Okay, otherwise, you could be working on a blank sheet of paper and maybe write out the questions yourself if that helps you, or you could just write your work on that separate sheet of paper. Just make sure it is very clear and easy to read. Okay. So let's take a look at a couple of these guys. But first off, we want to make sure we remember what our equation is all about. We have density equals mass over volume, right? That is our heart. That is our chemistry sign. Okay? And it lets us break down and set up our equation. So what I like to do is I like to read through my problems and use them to help me identify my variables and what I'm solving for. In this case, it says that I know the density of silver is 10.5 grams per centimeter cubed. I would usually like to underline that and write the variable there. So that's my density that I'm going to use in my equation. It says find the mass of, this is Ag, that's silver on the periodic table. So I'm looking for this mass value in this problem. And my last value here, so that find that mass of silver that occupies 965 cubic centimeters of space. I know this is volume for two reasons. It mentions space, which is talks about how much of space is measured in volume, as well as centimeters cubed is one of our volume units. So I have density, I have volume, I'm solving for mass. The way that I'd set this up next is I'd go ahead and start writing out my equation. I have density equals mass over volume. Okay. Right now, I cannot find the mass because it's on the side with the volume. So I need to set up my equation in order to get the mass by itself. There are lots of ways to think through this algebraically. Your instinct might be to get rid of the v and multiply it out. I like to think about cross multiplication though, because I've got a fraction. Okay? And cross multiplication is when you're dealing with fractions. And if you forgot, remember that any value, any variable or number by itself is also a fraction, just over 1. So I have d over 1 equals m over v. And here, I can just cross the problem and multiply those pieces. So I'm going to take m times 1, which m times 1 is just going to be m. So I have m that is going to equal my other cross, the density times the volume. And there we go. I've rearranged my equation. This is a crucial step in any problem in chemistry. If you're dealing with an equation, you need to rearrange it to solve for what you're looking for. But now we can just go ahead and plug in the numbers that we know, right? We have 10.5 grams per centimeter cubed. That's how you'd say that out loud. Okay, I have grams on top and centimeters cubed on bottom. And I'm going to multiply that by 965 centimeters cubed. Okay. These two numbers are going to come together and get multiplied and help us find out what our m is. We can write that final answer right down here. So I'm going to take 10.5 times 965. And I get an answer of 10132.5. And let's get that down. And my last part is to think about my units. Notice that I've been writing units for every single number, even in my work. Okay, work units are needed for every single number. Okay. Now, to figure out what my units are for my answer, I need to just go look back up here. You can see that up on in this number for the volume, I have centimeters cubed, and in the density, I also have centimeters cubed, and it's on the bottom of a fraction. So I have something on the top and the bottom. These can cancel out. This is the same thing you might have experienced in basic algebra, where if I had like x, y over x, the two x's could cancel out because one's on top, one's on bottom, just like this top and this bottom. So my answer for my units is going to be whatever is left, and that's going to be grams. Okay? So there's our answer for mass. let's go ahead and take a look at, we're going to skip number 2 for right now because that one's pretty easy. You're just solving for density. You don't have to do any rearranging of your equation, right? So let's skip to number 3. This one gets a little bit more interesting. Okay? We can see here that under certain conditions, oxygen gas has a density of 0.0134 grams per milliliter. There's my density. Let's mark it. And we're looking for the volume this time. Okay? Then it's occupied by 200 grams of oxygen under the same conditions. So we are looking for volume. We know our density. We know our grams, which is better known as our mass. There we go. That's what our equation has in it, mass. So let's set up our equation. We've got density equals mass over volume. This one becomes a little tricky for a lot of chemistry students because a lot of people's first instinct is to try to divide away the m, but that will not work in this scenario, okay? Because that would leave a 1 over v. Instead, we need to get the v out of the bottom here. This is where the cross multiplication comes in handy because we're just going to do the same steps we did for the first example. And I'm going to take mass and volume and cross multiply. So now I'm going to have density times the volume, right? Because that's this side's cross, density times volume. And it's going to be equal to mass. So in the last problem, we stopped here because we were looking for mass. But now I want to continue to solve my problem and solve for volume. So I'm going to go ahead and see that these two are multiplying each other. I'm going to undo that multiplication by dividing by density on both sides. So the density on this side is going to cancel out, and I'll be left with my final equation. Volume equals, you can see, m over d. Look at that. We've got our equation solved, and now we just need to plug in our numbers. We have 250 grams, don't forget that 0.0, divided by 0.00134 grams per milliliter. Awesome. So let's figure out that final answer in our calculator and check our units. I'm going to take 250 divided by 0.00134. Boom, I get a big old number here, 186,000. Whew, that's a big number. Let's write it down here. Okay. We've got 186,567.1642. Whew. And that's our units are going to be pretty simple. We're going to take our grams at the top and the grams at the bottom. Just like how these are at the top and the bottom, the grams are going to cancel, and we're left with milliliters as our final answer. Great. Our last chance is to go ahead and just make sure we check our answers on the back. So when I look here, I see that 101, oh, look at that, 10100, but I got this in my calculator. And something similar here for 3. Look at that, 18700. It's kind of like what I got. Mr. Bartlett. I see what we did here. It looks like we forgot to consider our significant figures. Okay? What I need to do is I need to look at my numbers in my problem to determine how many sig figs my answer should have. If you remember, our problems are determined by which one of our numbers has the least amount of significant figures. So back up here to number 1. This problem, 10.5, 1, 2, 3 sig figs, and then 965, that would also have 3 sig figs. Since these both have the same number of significant figures, I'm going to need to round my answer to 3 sig figs. So 101, those will be my first 3 significant digits, and then that'll be the end of it. I just need to round my answer now. Okay, so my final answer with 3 significant figures is going to be 101. The 3 and the 2 are going to get taken up by zeros to be placeholders and be left with grams as my answer for number 1. So we got this answer by rounding our significant figures. So let's take a look at the next one here. Remember that all of our leading zeros here are not significant zeros, but 1, 3, and 4 give us a total of 3 sig figs. And then 250.0, that decimal place means that we have 4 significant figures here. So I have an answer with 3 sig figs and an answer with 4 sig figs. So, assuming not answer, but part's my problem. So I'm going to round my answer to the least precise. That's the 3 significant figures. So I'm going to take this answer, round it to 1, 2, 3. That 6 is going to get rounded up to a 7 by the 5 next to it and be left with 1, 8, 7, 0. These 5, 6, and 7 at the end are all going to become zeros for our final unit of milliliters. There's our answers, and those neatly match with what we were given on our sheet here to check ourselves. So don't forget that sig figs in the end, and make sure you're being careful with your calculations and your units. It seems like a lot of work, but each step is simple. Take your time and always ask questions. I'll see you guys coming up soon. Let me know if I can do anything to help, and have a great rest of your day.